Okay, so epistasis. So what is epistasis? Epistasis is the interaction of genes at different loci. So if you remember the different loci on the genes, so there's the chromosome, well that's a very bad drawing, that's the chromosomes, and that's the interactions of genes at different loci, so that's the location on the chromatids. So the lacquer operon is a very good example of epistasis, with regulatory genes controlling structural genes. So if you remember the lacquer operon, it had operator regions and promoter regions actually operating. So this is the lacquer operon. So it had operator regions and the promoter regions, which were regulatory genes, which allowed to inhibit the production of the structural genes, which made the enzymes, which therefore coded for the proteins further down the lacquer operon. So the lacquer operon is a key example of epistasis, as it is regulatory genes controlling structural genes. So that is the interaction of different genes at the different loci. So you can have if you have a missing enzyme, so say you didn't have enzyme A, enzyme B, enzyme C and enzyme D, and if there's a missing enzyme, these enzymes help code for the next one. They all code for each other. And if you have, say, missing enzyme A, the intermediate molecule that's necessary for the next reaction to create enzyme B isn't there anymore. So this causes a lack of substrate. And this lack of substrate means the expression of the gene won't be in the phenotype. So this B gene won't be expressed in the phenotype because it won't be able to be coded for because the missing enzyme. So that epistasis is the effect that it can have on other genes. This gene is said that it is masked. This is how you say it's masked. By the lack of expression of the previous gene in the pathway. So gene B is masked by enzyme A, or enzyme is masked because it's not there, and then therefore it's not being expressed in the phenotype. A gene that is affected by another gene is called hypostatic, and the gene that is affected that affected the expression of the other gene is epistatic. Right. So to remember that, so enzyme A, gene A, let's call it. Gene A is the one that's affecting enzyme B. Oh, gene B even. So this one is called epistatic. And the affected, the masked one, is hypostatic. So if you imagine the gene B is hypostatic because it's very I don't really know how to explain that. Yeah. Or maybe it comes before the alphabet, so you have E first, because it comes first, that is what happens in the mechanism, and then you have hypostatic. I don't know how you ever remember it. So epistatic is the one that is the effector, and then the hypostatic is the effectee. You can also have dominant and recessive epistatus. An epistatic gene may influence the activity of other genes as a result of present dominant or recessive alleles. So two recessive alleles at a gene locus can lead to a lack of an enzyme. This would be called recessive epistatus. So the two recessive, as you can see, because they're not capital letters, the two homozygous recessive genes at the locus can lead to a lack of an enzyme. This would be called, so that would be called recessive epistatus. And then also dominant epistasis would occur if there's a dominant allele having the same effect on another gene, so that would also be epistatic, but that would be dominant rather than recessive. The gene at the E or the A locus is epistatic to the gene at the B locus. So that's just remembering epistatic first, and then hypostatic is the one who's being, yeah.